Alright, welcome back to the class. We have x exponent 3 equals 8. Okay, so we have x exponent 3 equals, now we can write 8 as 4 times 2. Okay, so our equation becomes x exponent 3 equals, now 4 is the same as 2 exponent 2. Okay, alright, so we are going to have x exponent 3 equals 2 exponent 2 times. Now, any number there has an exponent or a power of 1. So 2 is the same as 2 exponent 1. Alright, now that we have 2 exponent 2 multiplying 2 exponent 1, let's apply the addition law of indices. Okay, so if you have a exponent m multiplying a exponent c, this will produce a exponent m plus c. Now let's apply this concept to the right part of our equation. So you're going to have x exponent 3 equals 2 exponent 2 plus 1. Okay, alright, so you're going to have x exponent 3 equals 2 exponent 3. Alright, so you can see we have x exponent 3 at the left part and then 2 exponent 3 at the right part. Now let's transpose 2 exponent 3 to the left part of the equation so that we can apply difference of two squares, so that we can apply the sum of cubes, so that we can apply the difference of cubes identity. Okay, alright, so now we have difference of cubes, and so we can apply the difference of cubes identity. Now before we apply that identity, let's quote the formula for the difference of cubes identity. Alright, so let's do substitution. So you're going to have x minus 2, okay, and in this part you're going to have x squared plus 2x plus 4 equals 0. Alright, so this is what we have. Now, we have two equations here. Okay, so you can say x minus 2 equals 0. Let's call this equation 1. And then we have x squared plus 2x plus 4 equals 0. Let's call this equation 2. Okay, alright, so you can see in equation 1 we have a linear equation, and then in equation 2 we have a quadratic equation. Alright, from equation 1 we can see that x is equal to 2. Therefore, x1 equals 2. Alright, now from equation 2, okay, x squared plus 2x plus 4 equals 0. Alright, this is a quadratic equation, and so we can solve it using the quadratic formula. Now before we apply the quadratic formula, we need to understand the component of the quadratic formula, or we need to know the various components of the quadratic formula. And to know that, we quote ax squared plus bx plus c equals 0, also a quadratic equation. Now let's compare this equation to our own question, okay, or our equation. Now, so we are comparing this to this, okay, alright. Now when we compare, you find out that a equals 1, b equals 2, and c equals 4. Alright, now that we know the component of the quadratic formula, let's quote the formula. So you have x equals minus b plus or minus the square root of b squared minus 4ac. Alright, so this is what you have. Okay, So you're going to have x equals minus 2 plus or minus the square root of, now you're going to have 2 squared minus 4 times 1 times 4, which is c, all over 2 times 1, since a is 1. Alright, so you're going to have x equals minus 2 plus or minus, okay, 2 squared is 4, minus 4 times 1 times 4 is 16, all over 2 . Alright, so you're going to have x equals minus 2 plus or minus the square root of 4 minus 16 is minus 12, okay, all over 2. Alright, so you're going to have x equals minus 2 plus or minus the square root of, now minus 12 is the same as 12 times minus 1, okay, all this over 2. Alright, now here you're going to apply a law in set. Okay, this law is known as the product rule for square roots. So if you have the square root of a times b, this is the same as the square root of a multiplying the square root of b. So we're going to apply this to where we have the square root of 12 multiplying the square root of minus 1. So we're going to have x equals minus 2 plus or minus the square root of 12 times the square root of minus 1. Okay, alright, all over 2. Alright, now so you're going to have x equals minus 2 plus or minus, now 12 is the same as 4 times 3, 4 times 3 times, okay, so 12 is the same as 4 times 3. Alright, so we've brought our minus 1. Alright, let's proceed. So you're going to have x equals minus 2 plus or minus root 4 times root 3 times, okay, square root of minus 1. Okay, alright, all over 2. Note, if I say root, it means the square root, okay, so don't confuse yourself. So you're going to have x equals minus 2 plus or minus, and the square root of 4 is 2. Alright, okay, so our equation becomes x equals minus 2 plus or minus, now 2 times 3, 2 times the square root of 3 is 2 root 3. Okay, alright, okay, so here we're going to apply another concept. Okay, this is known as the definition of the imaginary unit. Okay, so if you have minus 1, this is equal to I squared. Okay, so we can write this, or we can say x equals minus 2 plus or minus 2 root 3 I. Okay, sorry, 2 root 3 times the square root of I squared. Alright, so this is what you have. Okay, all over 2. So make sure the I is not under the root, but rather a bit away from the root. Okay, All right. So you're going to have x equals minus 2 over 2 plus or minus 2 over 2 multiplying the square root of 3I, okay, or 3, the square root of 3 and I. All right, so we're going to have x equals, now you have 2 over 2. Here we're going to introduce a law known as multiplicative identity. Now this law states that any non-zero number over itself is equal to 1. Therefore 2 over 2 is 1. So here we have minus 1 plus or minus, okay, 1. Okay, so you can choose to ignore this one, okay, since its absence still indicates that there's 1 there, okay, so you can choose to ignore this one, okay. So this is our equation, and therefore you can say x2 is minus 1 plus the square root of 3I, okay, and then we can say x3 and then we can say x3 equals minus 1 minus the square root of 3I. Okay, so you can see we have x2 and x3. And now that we've been able to solve x1, x2, and x3, since since the question was, or since the question is, since the question involves cubes, okay, since the question involves the difference of cubes, let's organize our answers. So you have x1, you have x1, x2, x3. Okay, so x1 we have 2. x2 we have 1 plus square root of 3I. And then x3 you have minus 1 minus of 3I. So this is the end of the class.